Hello friends. So today we are going to start a new chapter in mathematics part 2. The chapter is differentiation. So if you want to understand differentiation, we must understand the basic definition of differentiation. So what is the basic definition? So basically the differentiation gives you the rate of change of function, the rate of change of a function, the rate of change of a function y equals f of x with respect to independent variable x. So it gives you the rate of change of function y equal to f of x with respect to independent variable x. Now when I say the rate of change of function, the rate of change signifies the instantaneous value. Rate of change. We can also have an average rate of change of the function with respect to variable, but that will be clear after going through this example. Now suppose we have a function y equals f of x, and let me plot that function to give you the, suppose we have let's say we have x-axis and y-axis, and we have a function here which is shown by this particular graph. Let's say this graph shows the variation of this particular graph is representing y equals f of x. So what is the significance of this? Suppose if I take any particular point here, this point has some x coordinate, let's say it has some x coordinate. So because this particular graph is following the function y is equal to f of x, so you will have the corresponding value of y given by this. So this is definitely the value of y. Now, so if you take another point somewhere here, let me take another point somewhere here. This is point 1 for instance, and this is, let me call point 2. So if you take point 2 here, it will have some next coordinate. So I will call this as x plus change in x, that is delta x. So correspondingly you will have the y coordinate over there, and that y coordinate is going to be y plus delta y. Y plus delta y. Now if you observe these 2 points, point 1 and point 2, there is a variation taking place, there is change taking place from, the function is changing from one value to another value. So if I want to represent it simply, I must say this is, if I represent these 2 points, these points are, this is y equal to f of x, and here the y will be equal to f of x plus delta x. So the value of function, that is y, is changing from f of x to f of delta x. Y plus delta y it is equal to f of, so it is y plus delta y equals to f of x plus delta x. So the entire, now if I want to find change from point 1 to 2, so if I want, there are two quantities, one is called as average rate of change. So in average rate of change, change of y is equal to f of x with respect to x. If I want to find this particular quantity, then it is given by change in y, divided by change in x. Very simple. So this is basically average rate of change, because we are taking them over an interval, so it is delta y over delta x. This is average rate of change. But if you want to find instantaneous rate of change, suppose you want to find instantaneous rate of change at particular value. So suppose you want to find out the rate of change at point 1. At this particular point you want to find rate of change. Then if you want to find instantaneous rate of change, then this delta x you have to make very small. Delta x you have to make very small, so that you will get an instantaneous rate of change. So this, which is variation you are making very small, that means that has to be very close to 0. So if you take very small interval, then that change is called as instantaneous rate of change. So, and that instantaneous rate of change is called as differentiation. So instantaneous rate of change or we can simply say, or differentiation of y, that is function, with respect to x, and this is given by dy over dx, which is derivatives we call, or differentiation. This is nothing but you have to make delta x very small, then this average rate of change will become instantaneous rate of change. So this is very important point to remember here. So if you take average rate of change, it is done over a large period, over a large variation, okay. But if you want to find instantaneous rate of change, so you have to make delta x very small, and to get that you have to introduce limit delta x tends to 0. So this is how we do differentiation. Now this can be simplified. So we have a called as first principle rule. So now I want to simplify the concept of differentiation. So by first principle or by definition we can say, so we can also call as first principle of differentiation, or simply definition. So what it says, a very simple rule we just discussed. So if y is a function of x is called as independent variable. We will discuss later on why it is independent or not. Right now it is not required. Y is a function of independent variable x. If y equal to f of x is a function of independent variable x, then the derivative the differentiation or derivative, you can write differentiation of y with respect to x is given as dy by dx, you can write, which is equal to dy dx, which is same as first derivative f dash of x, and which is equal to limit delta x tends to 0, change in y, actually it is change in y over change in x. This can be further simplified as a limit delta x tends to 0. What is change in y? That is final value of y, that is f of x plus delta x minus initial value of y is f of x divided by delta x. So this particular definition is called as first principle, rule of first principle. Now, by using this, we can derive some standard results. For differentiation. So let's do it. That's very simple. So I'm considering first one. When we have y or equal to f of x and equal to x raised to n. Okay. So this is the standard form of a function which is x raised to n. For example, you can have example here, y equal to x raised to 10 or y equal to x raised to minus 5, y equal to x raised to m, anything similar to that. These are example of polynomial function of x raised to n. Okay. So we can solve it by using first principle. We can apply first principle rule and we can obtain the expression for this differentiation. So let's do it. So y is f of x. So if there is small change in x, then you will get, so if x changes to x changes to x plus delta x, where delta x is a small change or infinitesimally small change, then y equal to f of x changes to y plus delta y, which is f of x plus delta x. So here delta y change in y. So you will get, therefore by definition, by first principle rule or by definition, we can write down dy by dx equal to limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. Very simple rule, and let us substitute the values. So we have limit delta x tends to 0. F of x plus delta x is going to be nothing but, if I write here, just you have to change x to x plus delta x. So x plus delta x raised to n. Okay. So x plus delta x raised to n minus x raised to n divided by delta x. Now we can change the limit here to simplify the problem. We have a very simple rule, limits rule, that is limits x tends to a x raised to n minus a raised to n divided by x minus a is n times a raised to n minus 1. This is a very simple rule. So by using this particular rule, if we have x here, we have a here, the same x and a should come here. In the similar way, we can change here also. We can change the limit. So how we can change the limit? Since we have delta x tends to 0, we can write, so since delta x tends to 0, we can add x on both sides. So that would give you x plus delta x tends to what you call x. So if you look at here, this is x for instance. So if this is x, this is a kind of thing similar to it. So we can write down here. So that will give you dy over dx equals limit. I'm just changing the format. So it is going to become x plus delta x tends to x, and here already we have x plus delta x raised to n minus x raised to n divided by, we have again delta x can be written as what? X plus delta x minus x. The same format is coming. Here you can, this and this x can be cancelled out. So seeing this format, using this result or limits rule, we can easily apply there, and if you apply it here, you will end up getting very simple rule. So n is what? Here n is same, you can see. We have again n here, so it will come out as dy by dx equals to n times, what is a here? Here it was a, here it was a, but now here it was, instead of a we have x. So you will get n into x raised to n minus 1. So you get a result. If it is f of x is x raised to n, so its derivative is n x n minus 1. That's the first result. Similarly, you can derive number of results, okay, and we can make a table, a concise table which includes all standard results.